In part 2 of this assignment, we were to create a meandering channel to run a Megaflood hydrograph through. We started with a 222 centimeter stream with a sinuosity of 1.3. The profile of the valley showed the right side of the stream floodplain to be a little bit lower than the right side, which comes into play later on in the recording. We started the flow at 55 milliliters per second. The flow was confined within a channel with natural levees on each side. 150 milliliter per second pulses were sent through the stream. Blue dye is used to show the path of the river. The original meandering channel formed within a meander belt with natural levees on each side. Because of the width of the belt, the channel was very confined. The channel also illustrated great examples of cut banks and point bars. We then ran the program's 16-minute Megaflood hydrograph. The elevated discharge quickly flows into the right floodplain due to its lower elevation. In this process, much of the original natural levee is destroyed. There is evidence of upwater extension of headwater channels due to groundwater sapping. The channel starts to show signs of a braided system near the base of the river. A good example of how a cutoff will increase sediment supply due to increased gradient is also illustrated. As the discharge lessens, a stable meandering channel is formed. Due to contact with the stream table wall, the stream elevation experiences a dip. Some levee remnants are still visible, as well as a channel that was cut off in the original flood. Flow is returned to 64 milliliters per second to re-establish the stream. An example of meander rotation is seen downstream in the river. Due to the large sediment supply in the middle of the river, much of the flow is turned into groundwater flow rather than overland flow. This results in losing and gaining streams. Discharge was increased in order to re-establish a continuous stream. At the end of the experiment, there is a notable decrease in sinuosity. Slope, sharing an empirical relationship with sinuosity, increases over time. The stream elevation of this meandering channel is also affected by the contact with the stream table wall. This contact also led to irregular channel activity. The final valley had many terraces present. This video was compiled in 7.5 frames per second.